But as I say, today's presentation is going to be on commissioning. I make it 10 o'clock, so we are going to get started right now. So yeah, commissioning. Let's start by talking about, what do we actually mean by commissioning. So, this is going to happen, generally speaking, it happens towards the end of the works or right at the end. But it could be full commissioning, it could be partial commissioning, or you could actually do commissioning in stages as well. Commissioning is basically preparing everything ready at the end of the project. So everything should be working. You can actually prove that everything is working. You're doing some tests, you're doing some checks, and then you're kind of signing a piece of paper to say, yeah, this is done. And obviously this is very important for contractual things. The contractor, in order to get paid, needs to provide this kind of commissioning handover, signed reports in order to kind of establish that the work has been completed to the correct standard, it's been checked, and then, like I say, they can actually get their money for doing that part of the works. So as I say, it does depend on the size of the building, really, as to how this will be managed. So, on the one extreme, if you've got a single family house, then the chances are that you would kind of you do all the installation, and then you do full commissioning all at once, and say that would all happen, in a relatively short period of time. At the other end of the scale, you might have, a large shopping centre, or a high-rise building, sort of complex high-rise building, in which case you're probably going to be doing sort of commissioning in stages. You might even have what's called a base build, where one sprinkler contractor is going to come in, they're going to install the tank, the fire pumps, the kind of distribution pipe work, the main sort of pipe work, and then branching off to each floor level or to each shop unit, they would then put an isolation valve, maybe the flow switch, or maybe a zone check, but say maybe just the isolation valve, and then cap it off, and that would be their work done. So obviously their commissioning would be concentrating on the works that they've done, and then it'll be up to another sprinkler contractor or multiple sprinkler contractors to kind of come in and then do the final bit from the zone valve to fit out the shop unit or to fit out the floor, and then their commissioning would be concentrating on the bit that they've done. That's all fair. You shouldn't be taking responsibility for works that you haven't done. So commissioning is focusing on the works that that you have done. So that's an example there of full, partial, and commissioning in stages. So as I say, it could be commissioning of an apartment, could be commissioning of a floor, and sprinklers is obviously just part of a much larger scope of works, which obviously the main contractor will be looking after. So in a block of flats, in a sort of an apartment building, you would be looking to get a whole apartment signed off. So yes, that'll be sprinklers, but it'll also be electrics, it'll be the water, it'll be gas, it'll be fixtures and fittings, maybe even painting, plastering. You want everything done, and then you can basically lock the door and say, right, that room is done. And as I said, there's a lot of coordination required between the various services, which we'll come on to a bit later. So you've got kind of commissioning as you go. It may well be that the sprinkler contractor is going to do some tests and checks independently, i.e. not sort of official ones, not kind of witnessed ones, but will probably want to do some commissioning as he goes to make sure that things are in order. And then say you would have final commissioning at the end, which is basically the important bit, the one that is going to be witnessed. It's going to be witnessed by relevant people. So again, depending on the complexity of the building, depending on the AHJs, remember them, the authorities having jurisdiction. So again, if it's a hospital, then presumably somebody from the NHS Trust would be there. The consultant may well be in attendance. The insurer might be in attendance, again, depending on what kind of system it is. The end user may well be there. Sort of managers, representatives. It very much depends again on each building each building in turn. But yeah, all the relevant people are going to be there for the final commissioning. There's going to be some demonstration of key parts, which I'll go over in a minute. You've got handover, which, again, all of these terms are, I think, going to mean slightly different things to different people. For me, handover is the literal handing over of various pieces of paper and documentation. And then end user training, again, important. You've got a sprinkler system which you're then going to be relying upon, either for property protection or life safety. It's important that somebody who's actually going to be on site, for the next few months and years, actually knows what they're doing. So there's going to be some end user training carried out as well. So commissioning, as for BSEN 12845. I've forgotten actually where this was in the standard. It's towards the end, obviously. Section 11, I think I would guess. Should have figured that out earlier. But yeah, here's a few points from commissioning, as in 12845. So pressure testing of all pipe work is required. You do all the weekly and quarterly tests. Completion certificate handed over. Any deviations from the standard and installation standards. As-built drawings, important. Complete set of operating instructions. That's what we call the O&M manual, the operation and maintenance manual. Inspected and signed off by a third party. So I'll put that in italics. So that is in there in the standard, but it uses some words that essentially mean if appropriate, if that's what's been agreed. Then it needs to be signed off by a third party. Let's say generally it isn't. And I think that quite rightly that the sprinkler contractor would say that if that's what you want, then you organise it and I'll cooperate. But it isn't something that the sprinkler contractor is going to kind of volunteer to do. As far as they're concerned, the work that they've done is good. They're self-certifying it, they're signing it off. But as I say, if you want a third party to have a look at it, then that can be done. And then, AHJ should receive copy of documents. So that's kind of a summary from 12845. Very similar for residential and domestic, in terms of what needs to happen. But obviously, it's on a slightly smaller scale generally, residential and domestic rather than industrial or commercial. There's some additional information from the technical bulletins. So, for example, pre-action systems aren't really mentioned in 12845, so there's specific tests for pre-action systems. There's a section that's all to do with the insurer. So again, depending on which property protection or life safety. So if it's property protection, the insurer is going to be involved a great deal more. So there's special instructions for that. And there's more detail, there's some more robust checks and demonstrations of the water supplies. 12845 is a bit sort of looser, I suppose, in terms of what exactly needs to be demonstrated, which you say is more clearly defined in the technical bulletins. So let's have a look at some of those things in a bit more detail. So first of all, pressure testing of pipe work. So all pipe work must be tested. This is a hydrostatic test, so this is putting water in. But before we get onto that, dry pipe work is tested to 2.5 bar. That's of air, so of air pressure, 2.5 bar for 24 hours, and no more than 0.15 bar loss is permitted. Okay, so any dry pipe work you'd fill with air, and then you test that. But then you would move on to a hydrostatic test. So I'm pretty sure that that's what it says in the standards. Just from reading kind of one point into another. But yeah, all pipe work should be tested to 15 bar or 1.5 times the maximum pressure. So if you've got 12 bar is your maximum pressure at the insulation control valve, then you'll be up to 18 bar. So 15 bar or 1.5 times the maximum pressure, whichever is greater. And that's a 2-hour test. And obviously any problems need to be rectified. So it would be a good idea, I think, for the sprinkler contractor to do that test, well in advance of kind of final commissioning, so that that there's a chance for things to be rectified if any problems are found. That is exactly the same for 16925. So BSEN 16925, the residential standard there, that says exactly the same, 2 hours, 15 bar or 1.5 times max pressure. Under 9251, it's 8 bar or 1.5 times maximum pressure. So again, it kind of adds up to the same thing, really. And that's only for 1 hour rather than 2 hours. So yeah, it's a bit of a difference. What are you checking for? Well, you're checking for any permanent distortion, ruptures, which I imagine would be fairly obvious, or leaks. Now, I understand from residential and domestic, if you've got plastic pipe, I believe that they would do an air test first, because an air test is kind of quicker, easier, and certainly less mess. So if you've got, say, CPVC pipe work, you obviously the major thing to watch out for is open ends. Your fitters, have missed a bit, and there's a completely open end of pipe somewhere. You're going to find that pretty quickly either way. But if you're doing an air test and there's no mess, if you come to do a hydrostatic test and find you've got an open end, then you've got a little bit of cleanup to sort out there. So yeah, an air test is kind of a good idea to do first. Little note here about checking with the manufacturer of equipment if suitable for a pressure test. So, this is, on the one hand, this is common sense. In kind of both respects, really. Yes, it's common sense to check, but, why is there equipment on there that is not suitable for that particular pressure test? They're both kind of relevant points. I know from Project Fire, obviously we're the manufacturers of our Zone Check product. So that the maximum working pressure is 12 bar for that. So we're not saying that it won't do a pressure test for 1.5 times, because absolutely that was part of the approval, that it could be tested up to that. So again, working pressure and hydrostatic pressure are two different things. We certainly do not recommend that the pump the pump on the Zone Check, not the fire pump I'm talking about, but that the pump on the Zone Check be run at higher than 12 bar. But yeah, it's absolutely fine to be testing it above, to the hydrostatic test. But we just say in our instructions, it's best practice to isolate the pump. So there's valves either side of the pump. So you close those, and then you do your hydrostatic test. So basically, you're not testing just a bit via the pump, so the pump doesn't experience 15 bar, 18 bar, but the rest of the pipe work does. So that's an example of just being on the ball about the equipment that you've actually got installed on the pipe work. What do they say in terms of going up to high pressure? But as I say, manufacturers should be on the ball because they should know that test needs to be carried out anyway. So all of this should be signed off with the engineer, so an engineer's signature, a time and date, the area tested. Again, you're probably not going to be hydrostatically testing, all of the system in one go. You're probably going to be testing each zone as a whole, or just the riser. And then, so you need some information about which bit you've tested. Pressure gauge calibration is important. So I've said maybe on the screen there. Maybe I should update that to probably. Gauge calibration, so you need to see some sort of certification. There's no real point doing a pressure test on a gauge which is unreliable, because it might be giving you the wrong reading. Maybe it's too low, which not really carried out the test, and maybe it's actually giving you a reading which is, so you're actually testing to a higher pressure that's required, which obviously may cause other issues. Witness signature, maybe. Photos, maybe. So like, taking a photograph of the gauge at the start of the test and at the end of the test, so you can sort of clearly see what the difference is. Again, it's going to vary from sort of job to job as to how exactly that will be done, but definitely, some sort of piece of paper to say that yes, that's been carried out. As I say, if witnessing is required, then obviously that needs to be coordinated and done as well. All weekly and quarterly tests complete. So this is just a kind of a reminder, really, of what that entails. So all the pressure gauges checked, position of all stop valves, exercising the valves, and the monitoring. So any monitored valve, then again, you need to be checking that the signals are coming through. Testing of all the alarm valves, all the fire pumps and jockey pumps set and tested. So again, that's setting all the pressure switches, making sure that the pump comes in at the appropriate pressure, the jockey pump coming in and out, so the cut in and cut out pressure of the jockey pump, and all testing related to that. Trace heating checked, sprinkler heads checked. So as far as commissioning and handover is concerned, remember all of those little clips need to be removed. And obviously heads and supports checked to drawing, are they in the correct position? Water supply checked, so we actually do a flow test, or that might be involving firing the fire pump up, doing that kind of test return and checking the actual flow. So we're actually checking that the fire pump, on each fire pump there ought to be a kind of a plaque, a metal disc, which tells you the manufacturer, the manufacturing number, the date of manufacture, things like that. But also, in very importantly, what duty is that pump designed to. And then you can actually do some testing. You can plot some points on a curve, and you can actually verify that the pump is actually doing what it's supposed to be doing. Electrical supplies, including backups, checking all those. All the flow alarms, so generally that's flow switches, and say generally that's zone checks. So that's going to save you a lot of time on commissioning, because you can they just turn a key or press a button to test those systems rather than draining water. Spares box, finally. So yeah, just checking that there is a spares box and it is fully stocked, which obviously it should be at the start of the job. Additional things. This is what I kind of other things to look out for. So, for example, checking the mounting of the fire pump. So that's very important. Has the plinth has been constructed with the right amount of thickness? Or, if there isn't a plinth, is the kind of floor that the pump's sitting on suitable for the fire pump weight? Are the bolts actually kind of got something to bite into, or are they going through the actual concrete floor? Because this is really important. That the fire pump is going to be spinning round really quickly. So if it's not securely fastened down, then it's basically going to shake itself to bits. So that's going to be very expensive, of course, but also, you're not going to get the desired sprinkler protection because your fire pump's in bits on the floor rather than actually delivering the water. So yeah, definitely looking into that. A colleague of mine mentioned to me about these ChemFix bolts. So you can have there's two different types of fixings. I forget what the other one's called. I've forgotten what it's called, but that's an example there of this kind of standard bolt fixing. But this ChemFix system involves like an epoxy resin filling, and that takes 72 hours to cure. So again, if commissioning is kind of being in a bit of a rush, what we don't want to happen is for them to kind of quickly fix the pump down using the ChemFix and then run the pump, because you're going to get problems there. All the signalling, so say every single thing which is monitored, every single panel that's displaying information needs to be checked. All cause and effect as well. So the sprinkler system Alarms may well feed into other systems, which are then doing other things. So all of that needs to be checked to make sure everything is working. Check drainage. Drainage is a common problem. Just undersized drainage, can be a real issue. So often that's specified well in advance, but then when it comes down to it, it's a case of, well, hang about, how come there's only a standard 25 or 32 mil drain here? We need a much bigger drain for our sprinkler pipe work, because we've got to allow for various things to happen at the same time. The tank may be overflowing, opening the drain valves on the alarm valves. Often all this equipment is in the basement, and so drainage can be problematic. So that just needs checking through. It's not the sprinkler contractor's responsibility to do the drainage, generally speaking, but you just need to make sure that is in place. High and low tank alarms, check accessibility of all equipment. So again, that should have been planned out well in advance, but can you actually get to everything for service and maintenance? And if you can get to everything, is it safe to get to everything? If you've got to sort of duck under a load of pipes, if you've got to crawl under something, is that safe to do so? Now is your sort of final chance to bring that up and get some changes made if necessary. Check the installation is in line with stage 3, so construction drawings. RCPs, reflected ceiling plan. So that's what you'll be looking at to kind of check the position of the sprinkler heads. You'll kind of be staring up at the ceiling, and you've got a drawing that kind of say is basically exactly that. It's looking up at the ceiling. So it's not from above looking down, it's from below looking up. Agreement for any changes in place. So it may well be that the sprinklers have not been installed to the stage 3 construction drawings, but if they're not, there should be some paperwork, some agreement in place to say, we found this problem and the instruction was given to move that pipe from here to here, or move that head from here to here. All of that kind of paper trail should be in place to show any deviation from the stage 3 drawings. Demonstration. Scope agreed in advance. I think for me that's a key one. Demonstration can take a very long time, and it's not really fair on the sprinkler contractor to kind of just basically rock up and say, right, I want to see this, and this. It should be agreed well in advance. What is the scope of demonstration? What do you want to see, so that everything can be put in place in advance. And so that might be absolutely everything. Like I say, it might be 100% of everything in the sprinkler thing you want to see and be demonstrated. Again, that's fine as long as it's agreed in advance. Or it might be a case of 50%. So it might be a case of, just show me half of all the monitored valves, and I'll take it on faith that the other 50% work. Or it might be another percentage that is chosen. So say you're kind of picking things at random to show that things are working without going through every single thing. Demonstration usually focuses on signalling and cause and effect, because that can be done from generally one location. You're setting things off, and do you get your signal, yes or no? It's quite a kind of binary thing, isn't it? It either works or it doesn't work. So that's quite a good one to demonstrate to other people. Here's an important one here: procedure for turning off in the event of accidental water release. So we need to make this absolutely clear. This is in the event of accidental water release. If you've got a fire, then the building owner, the maintenance team, whoever, should not be messing with the sprinkler system. It's a fire, leave it to do its job, call the fire and rescue service out, and they'll deal with it. And when it's confirmed safe, whatever, then you can work together to turn it off. But this is in the event of accidental water release, when you're absolutely sure there's no fire. What do you do? So again, it's very important for somebody on site to actually understand that procedure and what to do, because calling out your sprinkler service guy, with the best will in the world, is going to take them a few hours to get to you. So there's going to be a lot of water discharge by the time they arrive. So somebody needs to know what that procedure is. Go through all the tests and checks that the end user is taking responsibility for. As I said, they're preferably with that person or persons. So I say that there may not always be the case. It might be that the sprinkler contractor is handing over to the main contractor rather than to the actual end user themselves. But we just got to be confident that the main contractor is then going to demonstrate it on, or would either then ask the sprinkler contractor to kind of come back to site to then hand it over sort of a second time, demonstrate it a second time to the end user. We've got a sprinkler testing and maintenance schedule. But generally speaking, there's some responsibility for the on-site team to look after on a daily and a weekly basis at the very least, maybe more than that. So, whatever they're taking responsibility for, demonstrate it, show them, and get them to sign off to say, yeah, I've had my training and I understand what I'm doing. Again, that's important. Finally, handover of certifications and documents. So a signed completion certificate, giving the standard that's installed to, any deviations or non-conformities. Again, this is kind of the last chance to kind of get any of this kind of grey area sorted out. What have you done? Is there anything that I need to know about? Is there any deviation or non-conformities? If there's stuff on there that hasn't been discussed, now's your time to discuss it before you sign your name on a dotted line as well. After that, it becomes quite messy to get the sprinkler contractor back on site to fix anything, because you've signed it off. Complete set of operating instructions, in a manual, as-built drawings. So that's really important. So the as-built drawings are not necessarily the same as the kind of drawings issued at the start of the project. There may well have been things that were discovered along the way, clashes of different services, maybe a wall moved, etc. So it's not a case that, what I'm not saying is if the sprinkler contractor has kind of misinstalled it, has put it in the wrong place, and therefore updates their drawings accordingly. That's the opposite. That does happen from time to time, but most of the time it is a fact that other things have happened, which means that the sprinklers have to be moved, but the sprinkler contractor needs to kind of keep up to date with that and then produce as-built drawings, so that any future changes or maintenance, you actually know where all the pipes are going. So that's important. I believe nowadays a 3D model or an AutoCAD drawing may be appropriate, but mostly we're still working with as-built pieces of paper drawings. Program for inspection, testing, and checks. Just like you're buying anything else, that there's a manual there, and there's what you have to do. Like when buying a car, you've got your manual, which says after so many miles you need to do this, after so many miles you need to do that. Same with the sprinkler system. A 1-year warranty, I believe, is required. I don't think it's any kind of getting away from a 1-year warranty. Obviously, it might be more than 1 year, but 1 year is kind of standard, really. Service and maintenance plan. So it's quite common that the installing sprinkler contractor would then take on the servicing and maintenance for the first year, 3 years, 5 years, whatever's sort of agreed in advance. So that's quite common. But if they're not, then again, you need to pass that on to the person that is. Third-party inspection documents, if present, need to be there and signed off. So that's it really, as far as what is required. If you've got any questions, then please pop them in the chat, and I will have a look at those. And I've realised I've gone on for half an hour already, but just while we're on the subject, here's a few pictures from site, just out of interest really. give you a flavour if you've not kind of seen this kind of stuff before, of what it's like. So here's a picture of a very packed a very packed servicing riser. Where's the sprinkler pipe work? It's not there. This picture was actually taken, given to me by a colleague, where basically the sprinklers were the last service to arrive, and it's like, okay, where can we put our pipe work? Oh dear, there's no space left. So again, coordination, very, very important. That's an example there of sealing. Again, the point just being that there's lots of services fighting for sealing space, and you can see pipes are kind of overlapping with one another. It is very important that everyone kind of understands what they're doing. There's another one there, just showing you that the complexity of what's going on above your head when you're walking around, which say that the vast majority of people never see or never appreciate. This picture here is just showing so that there's a light fitting that's supposed to be going into this hole, and there's a sprinkler pipe above it. Again, who's at fault? Don't know, but it's just an example of found an issue, that pipe needs moving. Instruction given. Say if it's not the sprinkler contractor's fault, let's assume that pipe is in the right place, and maybe the lighting thing is changed and now they want it in there. Then the sprinkler contractor wants an instruction to actually move it, and then they would actually get paid for that variation. A couple of pictures here. So an alarm valve on the left-hand side there, with a what's it called, a gate valve as the isolation valve underneath there. On the right-hand side is a standard kind of pump controller. So you've got the lights giving any information about pump running, etc., pump on demand, and the main isolation switch. Again, that would form part of the demonstration and part of the procedure in an accidental water release. That's obviously a little bit before final commissioning. So yeah, a tank, a whole load of bits. That's a bit better. So that's all shiny and new, installed. You can just see on the top right-hand corner, you see all those wires coming out of the monitored valve. So again, that hasn't been done yet, so that needed to be wired and monitored somewhere. This picture here is just showing, you see in the white circle there, that the misalignment of on the right-hand side will be the fire pump. Sorry. On the left-hand side there will be the tank, and on the right-hand side we've got the fire pump, and that there's two flange connections there, and they should line up. The problem in this instance was that the plinth wasn't built high enough, so again that's something that needs to be corrected. So again, that's just something that ideally we want to find out as soon as possible, so that it can be fixed, rather than waiting kind of 1 week before final handover, and we've got a problem with the fire pump. Again, just seeing kind of behind the curtain, really, behind before this is all sort of boarded up and everything. That's a tank in the background there, and the fire pump installed. A zone check. So yeah, there we go. There's the sprinkler riser coming up. That's the grey pipe, and then we're branching off to the floor connection with the zone check. So again, that would need to be demonstrated. Activating the zone check and showing the monitoring of that valve. And that's it. Can't see any questions on the chat, so I'll take that as a compliment that there aren't any questions. But yeah, that's commissioning, handover, demonstration, training. Like I say, we can use all those kind of words really, but we're talking about actually making sure that we've done our job to a satisfactory level. That's what it's all about. So next week we'll be looking at the basics of sprinkler head layout. So this is kind of a common question to ask. How far apart should they be? How close should they be? How do we actually place sprinkler heads within a room? How do we kind of design them? So again, that's a big topic really, but I will give you the basics of how that is done, so you can appreciate what the sprinkler designers do. So, okay, thanks so much for listening, and I'll catch you again next week. All right, bye-bye.